Okay, ladies and germs, this is a quick video on Newton's law of cooling, something you're going to need to know for your semester exam next week. Newton's law of cooling indicates that the temperature of a warm object, like a cup of coffee, or as my example is going to be, a cake coming out of the oven, will decrease exponentially with time and will approach the temperature of the surrounding air. Naturally, if you leave a cup of coffee sitting out, it cools off until it's room temperature. The temperature, capital T for the temperature of lowercase letter t for the time, is modeled by capital T of t equals T sub A plus T sub 0, the quantity T sub 0 minus T sub A, times e to the opposite of k times t. That's a lot to remember, but that's going to be something you're going to want to remember for the exam right there, and you're going to need to know, of course, what those represent. T sub A is the temperature of the surrounding air. T sub 0, think of this as when time is 0, is the initial temperature of the object, whether it's a cup of coffee or a cake coming out of the oven. And the lowercase letter t is the time after which the object starts to cool. Now the K is something you'll have to determine. Sometimes they give it to you, but most times you're going to have to figure that out on your own. The value of K is a constant proportion that relates the temperature of the object to the rate of the temperature change. You'll see this again in calculus. Now, a cake comes out of the oven at 400 degrees Fahrenheit. Now, I made this problem up. I don't know if cakes are baked at 400 degrees Fahrenheit. Probably not. But it comes out of the oven at 400 degrees Fahrenheit and is placed on a cooling rack in a 75 degree Fahrenheit kitchen. After 5 minutes, the temperature of the cake is 350 degrees Fahrenheit. What will the temperature be 15 minutes after it's taken out of the oven? And we're going to round it to the nearest degree. Alright, well, the fact that they give us the 5 minutes and the 350 degrees is very useful, because that's how I'm going to find out what K is. They didn't give me K in this problem. So what do I know here? Well, I know the temperature of the air, that's T sub A, is 75 degrees. 75 degrees Fahrenheit. You don't need to put the symbol in when you're working the equation. T sub 0, it's coming out of the oven at 400 degrees Fahrenheit. So what I have here, let me go back to the formula. T of t is equal to T sub A, which is 75, plus T sub 0, which is 400, minus T sub A, which is 75, times e to the opposite of k times t. Now, I got to figure out what k is so that I can work this problem out. This is where I figure out what k is. 5 minutes when t, lowercase letter t, is 5, the temperature, capital T, is 350. So I'm going to write 350 is equal to 75 plus, now 400 minus 75 is 325, e to the opposite of k times the time, which is 5. And as you can see, you have an exponential equation that you need to solve. Let's get this all by itself. Let's subtract 75 from both sides. Let's divide both sides by 325. Hope I left myself enough room here. And let's see, what would that be? 11/13 if I reduce by dividing top and bottom by 25 equals e to the negative 5k. If I take the natural log of both sides, and I'm going to flip-flop the sides here a little bit. Oops, 13. And then I'm going to use the property that the natural log of e to a power is that power. I get negative 5k is equal to the natural log of 11/13, which I'm going to have to grab a calculator. Divide both sides by k, I get the natural log of 11/13 divided by negative 5. So you're going to have to grab a scientific calculator and approximate this. Now, being all over this problem, I approximated it to be 0.03341. Notice I didn't take it out to just like the tenths or the hundredths. I took it out a few decimal places because if I round now, when I get to the end here, I may be off a little bit. You don't want to do a lot of intermediate rounding. So I'm thinking that's plenty of decimal places, and this guy goes in there for k. So now my equation becomes T of t, capital T of t, is equal to 75 plus 325 e to, now that negative comes in, negative k 0.03341 T. Now the question says, what's the temperature in 15 minutes? So that means I want to find T of 15. 75 plus 325 e to the negative 0.03341 times 15. Well, it is time to grab a calculator again, and I'm going to punch this into the calculator, and I get approximately 271.896. And that's only out to 3 decimal places. Remember, it says rounded to the nearest degree, so after 15 minutes, the temperature of the cake is 272 degrees Fahrenheit. Now, it's a story problem. I wish I could get all my calculus students and all my pre-calculus students to remember that when they have a story problem, write your answer out in a short sentence. It doesn't have to be a paragraph. A short sentence. Make sure of your units and all that goes along with it. So there's the answer to this problem. Now you may have noticed down here I have like a second part to the problem, because in this case it says how long until the cake is 150 degrees Fahrenheit. This time I'm looking for time. They give me the temperature. It took 15 minutes to go from 400 down to 272, so I'm pretty sure this answer is going to be bigger than 15 minutes. Let's figure that out to the nearest minute. So now I go back to this guy right here, and I am going to plug 150 in for the capital T of T, because I want to know how much time has to go by before my temperature drops all the way down to 150, which is the time, of course, to get some cake and get some ice cream maybe and such and enjoy it while it's still warm. So I'm going to go 150 is equal to 75 plus 325 e to the negative 0.03341 t. Subtract 75 from both sides. Divide both sides by 325. Definitely need that calculator. Now I can divide top and bottom by 25. I get 3/13 equals e to the negative 0.03341 t. I'm going to, again, just like I kind of did back here, I'm solving for this variable that's in the exponent. I'm solving for t this time. I'm going to take the natural log of both sides because it's base e. And hopefully you can still see this. Okay, the natural log of e to this power is just that power. So over to here, I'm going to write negative 0.03341 t is equal to the natural log of 3/13. This expression becomes this. This stays the same right now. I'm going to divide both sides by negative 0.03341, negative 0.03341, and as I mentioned before, I better have a calculator close by. I did this earlier so that I could figure this out, and I get this to be, I lost my work. I get this to be, I get this to be 43.8. 0.889. 43.889. So that means it's going to take to the nearest minute 44 minutes. So how long until the cake is 150 degrees? It will take 44 minutes for the cake to reach 150 degrees Fahrenheit. And again, notice, not a paragraph, just a short sentence that kind of explains what's going on. So here are the two answers to the two types of things. Now guys, remember this, you have a better chance of remembering this if you practice this. There's one on the review sheet, there's also some in the book. Chapter 3, maybe section 1. I'm trying to remember now off the top of my head. So you can practice that as well. But you're going to need to know this one. you're certainly going to need to know A is equal to P times 1 plus R over N to the NT for compound interest, or when the interest is compounded continuously. I would know that one as well. Any formula that pops up that on problems that you're doing from the semester exam review, make sure you know that. Now, you don't put it on a 3x5 card and try to smuggle it in. Don't write it on your palm. Practice it, memorize it so that you're ready for that exam. Do some studying prior to Wednesday, or it's going to sneak up on you here. So be careful with that, and I hope that this helps with Newton's law of cooling.